Hi, my name is Cory, and I'm a CG specialist here at Chaos Group. I'm very excited to share with you today our new renderer, Vray 5 for Maya. We'll go over many of the powerful new features that will speed up your workflow, while giving you even more control and flexibility over your images in post-production. We'll begin by exploring the newly supported ACEScg color space, along with a few UI updates, including the newly redesigned V-Ray frame buffer, where you can manage your renders and do extensive post-processing. Next, we'll cover the completely new Vray Proxy, with its in-depth hierarchy and override functionalities that make it faster, more flexible, and handier than ever before. We'll then cover some updates to materials in Vray 5, including material presets, as well as the new coat and sheen layer parameters. We'll also take a look at a few new randomization options, including the handy new Stochastic Tiling mode, as well as utilize the upgraded V-Ray Dirt to create procedurally generated streaks. Then, we'll check out the new improved sky in Vray 5, which gives you even more dynamic sunrise and sunsets. Finally, we'll explore some of the powerful new post-production tools available in Vray 5 for Maya, including the new light path expressions, which make it possible to extract specific lighting events from the scene for very fine-tuned control of the image and compositing. In addition, you can go beyond rendering and do light mixing, as well as do extensive compositing, all with the new V-Ray frame buffer in Vray 5. Okay, I've opened up a Maya scene here that I'll be working in throughout this webinar. Let's get started by taking a quick look at the V-Ray settings. I'll be using the V-Ray render engine for this scene, but note that the features we cover today also work on V-Ray GPU as well, so you can use whichever render engine best suits your preference. Regardless of which you choose, Vray 5 is designed to give you great-looking renders right out of the box, using just the default settings for most scenes. Now, I'd like to start with taking a quick look at the new color space options that you can take advantage of with Vray 5, and cover a few UI changes we made to the Render Settings UI. In the V-Ray tab here, let's drop down the color mapping settings. Here, we'll find a menu for changing the rendering color space. You'll see here that Vray 5 now comes with a native implementation of the ACEScg color space, which is the Academy color encoding system, developed by the Academy of Motion Picture Arts and Sciences. ACEScg works with a lot more color information than sRGB, and has become the industry standard of the ACES encoding system for computer graphics. In Vray 5, there are two ways to render in ACEScg, either switching the rendering color space here, or using the recommended approach, which is to leave this color space on the default from Maya preferences, and specify ACEScg as the rendering color space in Maya's color management preferences. Then you can use the color management rules to automatically apply the input color space for your textures. Each of these methods has further considerations regarding the color space for certain textures, such as bump mapping, normal mapping, and displacement. You can also still override the color space of specific file nodes for textures not covered by the Maya color management rules. Since you'll need to decide which workflow best suits your specific scene, we recommend that you take a look at our docs page for additional information about rendering with ACEScg. For example, the OpenColorIO variable is still an option in Vray 5, and you can follow the steps in our docs for more information. Okay, let's also take a quick look at the DMC sampler settings above. If you're familiar with past versions of V-Ray, you'll see here that we've simplified the DMC settings so that all the sampling of shading effects is fully automatic. To control the shading quality of your image, you only need to use the image sampler settings. In addition, we've added the new blue noise sampling method in Vray 5, which is a checkbox here that is enabled by default. Blue noise sampling automatically produces a more pleasant result for renders that have low sample counts, or in situations where you're using depth of field or motion blur. It is generally most noticeable when rendering lower quality images with fewer samples. Alright, let's close the render settings and click on this icon here to open the newly redesigned Vray 5 frame buffer and explore the powerful new functionality it offers to enhance your workflow. To start, you'll see that we have some icons along the top right here. These are our main render controls, which include the render and interactive rendering buttons, as well as debug shading options for viewing the render in different shading modes, the ability to save our image, and so forth. On the left here, we have the Render Elements dropdown. If I click on File, Load Image, I can import an image I've saved in advance. Now we can use this dropdown here to switch between the different render elements that were rendered with this image. We also have a button here to toggle between the RGB and alpha channels. Next, if I double-click on this handle on the left, I'll open up the History panel. Here we can store a history of rendered images with their post-production corrections, and do A/B comparisons between images. There's also a search bar you can use to filter the image history based on scene paths or notes you've added to the images. Right-clicking on any image lets you add a note, as well as access other options, such as loading in the post-processing layers from a saved image, a topic we'll cover more about in a bit. Down below, we have a toolbar that gives us pixel value and coordinate information based on where our mouse is hovering over the image, which can be displayed in different formats. Now, let's double-click the handle on the right here to open up the new Layers panel. In V-Ray 5, you can now manage all of your post effects in this layer tree-based editor. This panel contains powerful tools and an intuitive workflow for doing color corrections. You can see that the image I loaded in already has some color corrections here in the layer tree. These include corrections such as the lens effects, denoiser, filmic tone mapping, and so forth. If I select a layer, for example, let's select the lens effects, we can go to the Properties section to make tweaks to its settings, such as adjusting their intensity, which you'll see updates our image right away. I can also hide or unhide layers by clicking on the eye icon next to each layer. If I click on the source layer, the properties will show us the option to switch between three modes: the RGB image, the light mixer, and the compositing mode for further adjusting your image. We'll cover these modes in more detail later on. Up at the top of the layer editor, you'll see we have a set of icons that let us create and delete layers, save and load in layer tree presets, get quick access to saved presets, and undo or redo changes. If I click on the Create Layer button, you'll see we have a variety of layer options to choose from, which we'll explore in depth later. You'll find similar options in a context menu if you right-click on any layer as well. Lastly, there is a Stats tab here, which gives us useful information about the scene, such as performance and memory tracking data, depending on the scene and the rendering mode. Okay, let's collapse the Layers panel. Note that if you need to make any adjustments to your VFB setup, such as specifying your VFB history folder path, you can do so in the VFB settings located under the Options menu at the top. Now that you've been introduced to the overall layout of the new V-Ray 5 VFB, let's take a look at an exciting new feature, the new Vray Proxy, which gives you increased performance and functionality to speed up your workflow. In V-Ray 5, we have completely overhauled the Vray Proxy with entirely new functionality that makes it more powerful than ever. The Vray Proxy loads geometry from file on disk at render time only, allowing you to render scenes with many millions of faces, more than Maya itself can handle, since the geometry is not present in the scene and does not use up resources. The Vray Proxy node loads Alembic or ABC file formats, as well as our native Vray Proxy file, in the VRMesh file format. Any mesh can be exported to these formats from Maya and then loaded in as a proxy. And, if you're working with an older scene containing the old Vray Proxy, it can be easily converted to the new Vray Proxy using the built-in Convert to New Vray Proxy node tool, which you'll see is located here in the Vray Tools menu. When using either the VRMesh or Alembic file formats, everything that is needed to render the mesh is included in the file, including a simplified version of the mesh for preview purposes in the viewport. To demonstrate, let's switch cameras here and then try loading in a Vray Proxy using the VRMesh format, though you can also use the Alembic format since the new functionality works for both. I'm going to click on the Import Vray Proxy button up here in the Vray UI, although you can also just drag and drop a VRMesh file into the scene. You'll see that we're prompted with an import menu here. Let's load in a building geometry as a proxy, which I've prepared in advance for this scene. Also, let's make sure the Use the new Vray Proxy node checkbox is enabled so that we use the new functionality. Note that you can also set the geometry preview mode for the proxy before import. This means that if you want to load in the proxy right away and have 0 reads of the file, you can set the geometry mode to none. If you set the mode to full geometry, you'll have additional preview functionality in the viewport regarding materials and hierarchy highlights. In this case, let's import this single building proxy in the full geometry mode and press the Create button to load it in. Now, you'll notice right away that the geometry loads in pieces to give us a preview in the background. Maya's functionality remains fully responsive, and we can keep working while the proxy finishes loading. Note that the proxy also loads in faster and gives you better viewport performance compared to the old proxy, especially for animations, and it even renders slightly faster as well. Once the geometry has finished loading, you'll see that we have a unique looking wireframe outline, which indicates to us that it is a proxy. Now, in the attribute editor on the right, we have a bunch of proxy settings, including the new Object Hierarchy dropdown. This lets you view the full hierarchy of the proxy file contents to give you much greater control over the proxy, and works for both Alembic and VRMesh files. Depending on how you've set up your geometry before exporting it as a proxy, you'll be able to quickly navigate your proxy's object hierarchy with ease. For example, if I select something, you'll see that it highlights in the viewport to indicate what parts of the proxy geometry are selected. And note that at the bottom of the object hierarchy, the proxy's materials are listed as well. If I click on the little eyeball icon, I can turn off visibility here for an object group, so that I can hide specific pieces of the proxy's geometry. We can also use the Override Visibility button below to accomplish the same thing. These are both examples of a hierarchy override. With the new Vray Proxy, you can use either hierarchy overrides or advanced overrides to override materials and geometry visibility. For example, we can override materials with new ones if we select a material and then choose the Override Shader button. If we click on the texture swatch icon here, we can replace the proxy's material with a new Vray material and then tweak it a bit. For example, I'll change its color to a reddish pink and tweak a few other parameters here just to make it stand out a bit. Note that you can even override materials by dragging and dropping materials directly onto the hierarchy. Okay, let's return to the object hierarchy and head down below to the advanced overrides. These overrides are executed before the hierarchy overrides and enable us to set rules consisting of the name or path of an object from the file's hierarchy to override the visibility or shader for the rule. Simply clicking Add New Item lets us type in an object name or the path of an object from the file's hierarchy to identify. For example, I'm going to type wall into the visibility override and also put asterisks on either side of it. These asterisks act as wildcards, which when placed on either side of the name of an object, such as wall, will match all objects that have the word wall in their name. Now I can toggle the visibility of the wall objects using this checkbox here. Note that you can also use an asterisk at the end of a hierarchy path to then match all objects contained inside a group. If you're unsure of an object's name or path, you can even select an object or group in the hierarchy, select its path, and middle mouse drag it into the advanced overrides to copy the path into a rule. This same rule-based functionality applies for the shader overrides below as well. If we add a new item, we can identify geometry with this rule, then connect a scene material and assign the shader to the objects matched by that rule. Both advanced overrides and hierarchy overrides can be used at the same time together. These advanced rules are intended for general, large-scale override assignments to capture multiple objects at once. Meanwhile, hierarchy overrides give you straightforward controls for more granularity. To see more information about how to format rules and other override capabilities, you can take a look at the V-Ray for Maya docs page for the Vray Proxy. Alright, now that we've explored the new Vray Proxy, let's delete these rules and material override, and move on to take a look at the new material presets available in V-Ray 5 for Maya. Looking back at the render we loaded in earlier to the new VFB, you'll see that we've got a bunch of materials here on the motorcycle. If we were just beginning to shade our scene, we might find it helpful to have some presets to start with that we could then fine-tune further. In V-Ray 5, we've made it possible to quickly and easily set up common materials, such as metals, glass, plastic, fabric, water, and so forth. Instead of spending precious time looking up IOR values, you can speed up your workflow with just a few clicks and get realistic-looking materials to use in your scene right out of the box. Let's head back to our scene and switch cameras so that we are focused on the motorcycle's fuel tank. Then, let's explore how we can use different material presets to get started shading. To use the presets, let's first create a V-Ray material and apply it to the motorcycle's fuel tank. Then, we can click on the Presets button up here at the top right to replace our current material with a preset material from the menu. The presets are separated into categories, so you can easily find metals, fabrics, and other dielectric materials. Let's try using something a bit unorthodox, but which might look interesting on a motorcycle, like this ceramic material. To use the preset, I'll choose Replace, and let's take a look at the result in the IPR. Okay, that looks pretty interesting. I like how we're getting these striking reflections from the jacket as well. Let's try out a few other presets now, just to demonstrate. This time, I'll try replacing the material with the plastic preset. Alright, that looks pretty nice. Now let's try something more unusual, like maybe this metallic aluminum brushed preset. Now that's giving us some interesting reflections. As you can see, there's an extensive variety of presets for you to choose from and experiment with. More importantly, they can give you a quick starting point that you can then further customize and refine, saving you time so that you don't have to build materials completely from scratch. In addition, you can test out presets for ideas and experimentation, and you may even discover some distinctive results that you normally would not think to try. And that's not all. We've also added some new parameters to the V-Ray material, such as the coat layer dropdown, which makes it incredibly easy to give your materials a sleek and glossy finish. To demonstrate, I'm going to assign a carbon fiber material that I set up in advance, and then let's tweak the coat parameters to see how we can improve it. You'll see here that this carbon material looks pretty nice, but it's missing that shiny finish that we would normally expect to see on a bike. To create this effect, we can head to the coat layer dropdown, where you'll see that we have some straightforward and powerful parameters that we can use to enhance our materials and textures. The coat amount is of particular interest, since it controls the blending weight of the coat layer. 0 means no coat layer, while higher values blend the coat gradually. In this case, let's simply increase the coat amount to 1 and see how that looks. You'll see right away how the material really starts to shine and embody a polished, glassy character, giving us some nice and sharp reflections too. The material could easily be further refined using the other coat parameters as well. For example, introducing some color to the coat, or tweaking the IOR value to distort the reflections. But in this case, I think the coat looks great with just the default settings. Alright, let's go ahead and stop the IPR. You can see now how the coat parameters make it easy to experiment with glossy and reflective coat layers, without any need to set up complex blend materials. It also renders faster than a blend material, so you can stay focused on the creative process and get results quickly. Okay, let's switch cameras here to take a look at a piece of cloth in our scene, and see how we can create a realistic looking fabric material using the V-Ray material's new Sheen layer parameters. These parameters enable us to create a cloth-like appearance. You can see here that we've got a crate box with a piece of cloth strewn across it, as well as the V-Ray material already set up that has a cloth texture plugged in. Let's go ahead and select the cloth, and then in the Attribute Editor, scroll down to the Sheen Layer Parameter dropdown. The Sheen parameters act as a top reflective layer on the diffuse color, allowing us to create a fall-off effect for cloth with straightforward controls. This way, we can create materials such as satin or velvet. Alright, let's start the APR again so we can see what the cloth material looks like without any of the Sheen parameters enabled. You can see that we have a nice looking texture for the fabric, but it's missing that fall-off effect that makes it appear like a textile material. To fix this, let's first adjust the Sheen color to something we'll see pretty visibly, like a light yellowish orange color. Next, let's increase the Sheen amount. The higher the amount, the more of the Sheen color you get. Finally, I'm going to lower the Sheen glossiness, which controls the sharpness of the reflections. Higher values let more light reach the diffuse, therefore diminishing the Sheen's visibility, whereas lower values reflect more light, making the Sheen effect more pronounced. Okay, great. Now you can see that the fabric is looking much more like cloth thanks to the Sheen layer, which is giving it a nice additional warm glow across the folds in the top left, and adding a natural looking fall-off effect. Altogether, the new Sheen parameters make it incredibly easy to give our material the soft reflective character of fabric without any need for complex shaders, so that we can work faster while getting realistic looking results. Now that we've explored some of the new shading parameters in V-Ray 5, let's move on to take a look at the powerful new randomization options we've introduced. These options make it incredibly easy to create randomized looking textures in your scenes. First, I'm going to switch cameras to a perspective of the ground surface here. Then, let's go ahead and start the APR again, so we can see how it looks. You'll see right away that the ground has a very repetitive texture with a visible pattern at the moment. Let's go ahead and save this image to the VFB history so we can do a comparison later. And then, let's see how we can use the new Uvw Randomizer Texture in V-Ray 5 to make this pattern less visible and blend in more naturally with the environment. Let's open up the Hypershade, make sure I've got my material here for the ground, and then let's add the V-Ray Uvw Randomizer Texture. I'm going to delete the Texture Placement node and replace it with the existing one I have set up here already. Note that you can also use the Placement node that comes with the Uvw Randomizer as well. However, the Placement node I have here is already set up with specific tiling values that I know work well for my scene. Now let's see how to hook up the randomizer to our current node setup. The Uvw Randomizer works by connecting it to the UV coordinate attributes of texture nodes. If I go ahead and link it up to each of my textures here, I can then use the Uvw Randomizer's parameters to apply random offset, rotation, and scale to these textures. You'll see how this can be a very powerful tool, because with a few quick tweaks, you can take repetitive looking textures and make their patterns much more subtle and random looking. In the Attribute Editor on the right, you'll see here the various parameters we have to work with. I'm going to leave the By Node Name mode checked, which generates the color index based on node names. However, I'm also going to enable the new Stochastic Tiling option, which changes the mapping based on the UV tile. Let's see now how this affects our image in the VFB. You can see that the pattern has already become significantly less noticeable, with the stochastic tiling helping to make the texture much more irregular. However, we can also tweak the variance offset parameters here to go further. The UV offsets control the position of the texture along the U or V axis, while the variance UV rotation and scale parameters control the rotation and scale of the texture. Let's lower the variance's U scale percent to 15 so that it scales on the U axis from 15 to 100. There we go. Now you can see that this has helped to even further diminish the visible patterns in the ground texture. Alright, I'm liking how that looks. Let's go ahead and save this render to the VFB history, and then do an A/B comparison of our two renders, before and after adding randomization. As you can see, the new randomized version has largely removed the pattern that we could see previously, while also making the ground less symmetrical and more aesthetically interesting. I think this will work great for our scene. Now that you've seen how we can use the Uvw Randomizer to quickly randomize our textures, let's stop the APR and explore a few other randomization options available in V-Ray 5 for the VRayMultiSubTex. I'm going to switch cameras again so that we're focused on a rooftop in the scene. First, let's hide this solar panel here temporarily so we can focus on the rooftop's material. Now, let's open up the hypershade and find the material I've already applied to the rooftop in advance. Then let's start the IPR to see how it looks. You'll see that at the moment, we just have a plain-looking V-Ray material applied to the roof. Let's see how we can take this plain-looking material and add some randomization to it using the VRayMultiSubTex, which contains new randomization parameters in V-Ray 5. Back in the hypershade, you'll see that I have already plugged in a VRayMultiSubTex, but it is not yet contributing any randomization. To get started, let's first review a couple of the key parameters. The multi-subtex enables you to distribute multiple textures to many objects via a single material, based on specified IDs or a random distribution. First, you'll need to set the getIDFrom mode to establish what ID to use to feed the multi-subtext data to the material. We have options ranging from useObjectID, which considers the object IDs of the object, to a few random by modes for assigning random colors based on an ID type, to the texture switch mode, which lets the switch texture parameter determine which texture is used for the material. I'm going to use the random by node name option, which generates a color index based on the name of the node that the texture is applied to. Next, in the texture list, I'm going to click Add New Item to add a subtexture or a texture, and then let's set the texture's color to be a light brown. Now, you'll see in the IPR that our rooftop has changed to a light brown color as well. Next, I'd like to experiment with a way I can randomize the color a bit, and also see if I can make the colors stand out a bit more. Back in the attribute editor, you'll see we have 3 new randomization controls for hue, saturation, and gamma. Each of their input values are a percentage of the hue, saturation, value, or gamma range. Let's try increasing each of these parameters just a bit to see what effect they have on our rooftop. Also, as a general tip, you will likely want to avoid setting these values too high, or they can end up having an overpowering effect on the image. Alright, now you can see that we're getting some nice randomized color hues across the rooftop, with a decent amount of saturation that makes them pop out, as well as some noticeable contrast among the colors, thanks to the random gamma. By just tweaking a few simple parameters, we've managed to take a plain brown colored rooftop and turn it into something much more dynamic and interesting to look at. Now, let's take a look at what happens if we drag a texture into the texture list's texture slot. I'm going to hook up a diffuse bitmap here and leave our randomization parameters as they are so we can see what effect this has on our image. Now you can see that this has altered not only the randomization of the colors, but we're also seeing some of the texture's corrosion now on the metallic sheet metal. As a result, you can see how these randomization parameters can be combined with textures to create even more complex randomized looking materials for your scene. By simply applying a few tweaks to the hue, saturation, and gamma parameters, we were able to easily randomize the colors of the rooftop. Now, you can see how the multi-subtext's powerful randomization controls make it easy to introduce more variety to your textures when you need it. In this case, however, you'll see that the texture I prepared in advance already has some randomized colors baked into it to begin with. So let's go ahead and return the randomization parameters to 0 and move on to explore the updated V-Ray dirt texture. First, I'm going to unhide the solar panel geometry we hid earlier. I'd like to explore how we can make the solar panels look a bit more weathered and grimy by adding procedural streaks with the updated V-Ray dirt texture in V-Ray 5. In the hypershade, you'll see here that I've already got a blend material set up and applied to the solar panel, which also includes a V-Ray dirt texture. The V-Ray dirt texture can be used to simulate a variety of effects, for example, dirt around the crevices of an object, or to produce an ambient occlusion pass. In V-Ray 5, we've updated its functionality with additional parameters that make it possible to create directional streaks, which can be very useful for adding procedural dirt, grime, or other weathering streak effects in your scene. Since I've already got a V-Ray dirt here ready to use with our scene's shader, let's proceed forward with it to make some adjustments. First and foremost, I'm going to switch the occlusion here to the new inner occlusion mode in V-Ray 5. This changes the direction of the rays being traced allowing me to apply the occlusion effect to the surface of the object. So instead of crevices, open corners will be shaded with the occluded color. Let's take a look now in the IPR to see how the solar panel looks at the moment. Next, let's scroll down to the new Directional Streaks section and enable the Inner Streaks checkbox. This will draw streaks across the dirt effect respective to inner occlusion, which we just enabled with the inner occlusion mode. Now, we can use the directional bias parameters up above to control the direction of our streaks. In this case, let's increase the directional bias for the x-axis, just so you can see how the dirt effect is forced in a certain direction using this parameter. Now, you'll see that we're starting to get a bit of a dirt effect coming in from the sides of each of the panels. I'm also going to draw a render region here around the solar panel to focus on that area and get a faster render result as we make further tweaks. Let's bring the directional bias X back down to 0, and this time increase the directional bias Y to around 10 to see how that looks. Now, you can see that we're getting streaks coming down from the top of each of the panels. Next, let's also tweak the radius parameter, which determines the amount of area in scene units where the V-Ray dirt effect is produced. I'll bring this down to around 20. Now you'll see that the dirt streaks are not as long, since we reduced their radius. I think they're a little too short though, so let's bump the radius back up to around 30 or so, just to make the streaks a bit longer. Okay, lastly, let's return to the Directional Streaks dropdown and adjust the streak size parameter here, which controls the thickness of all the streaks. Let's try increasing that to 50. Now, you can see that our streaks are much larger and thicker in appearance. However, I think this is a bit too large, so let's lower this back down to 20. I'm also going to turn off the render region, and then let's plug in the rest of the solar panel's materials. I'll replace the blend materials gray base material with a shiny textured solar panel material that I set up in advance, and let's see how this all looks together. And there we go. Now you can see that the dirt streaks are contributing some natural looking grime to the solar panels in our scene. This helps to give the scene a more realistic and weathered looking appearance, which we achieved by simply tweaking a few key parameters and using the powerful new directional streaks in the V-Ray dirt texture. Okay, let's switch cameras and then take a look at the new improved sky in V-Ray 5. The V-Ray sky is a texture map that is typically used as an environment map to help simulate outdoor lighting, which changes its appearance based on the position of the V-Ray sun. In V-Ray 5, we've introduced the new improved sky model, which is an analytical sky model that gives us especially striking sunrises and sunsets. It is also useful in cases where you do not want the sun to be positioned completely above the horizon. Currently, the V-Ray sun and sky that have been lighting this scene are positioned off screen, so I'm going to reposition the sun to be visible from this camera. I've already animated the sun in my scene, so I'll click here in the timeline to a spot that I know works well for this camera angle. Now, let's select the sun here in the viewport and then go to its settings. You'll see here that the sky model is set to ACEScg, which is a sky model available in previous versions of V-Ray. Let's first take a look at the ACEScg sky in the IPR for comparison. Alright, you can see that the ACEScg sky is giving us a decent looking result with a mix of yellow, green, and blue colors. Let's go ahead and save this render to the VFB history so we can revisit it later for comparison. Now, I'm also going to lower the height of the sun a bit by clicking further down in the timeline here, so we can get more of a sunset look. You can see that we're now getting a much stronger sunset vibe with the ACEScg model, showing a nice mix of orange and yellow colors. Once more, let's save this to the VFB history as well. As you can see, the ACEScg sky gives us pretty decent looking results. However, I'd like to see if I can get something even more dynamic looking, with a more contrasty mix of colors. For that, we can switch to the new improved sky model. Let's also revert the sun's position to its previous location in the timeline. Okay, great. Let's now head back to the VFB and see how it looks. As you can see, we're getting a larger range of color hues here, with a nice soft mixture of purple, pink, red, orange, and yellow. This gives us a really rich and vibrant sky that I'm liking a lot. Let's now save this image to the VFB history so we can do a comparison in a moment. Now, let's also lower the position of the sun using the timeline again, so that it is dipping below the horizon line. Now you can really see how the sky changes as the sun becomes a darker, fiery orange color, with a nice warm glow around it that dissipates smoothly into a cool evening blue. What's more, when you change the sun's size multiplier for the new improved sky, this will also affect the color of the sun itself, for example, to make it a darker red color. In this case, however, I think this size works well for our scene. Now let's go ahead and stop the IPR, and then save this to the VFB. Next, let's do an A/B comparison between the HOSEC sky and the improved sky results for these two sets of images. As you can see in both cases here, the improved sky has a more drastic and contrasting shift in hue based on the position of the sun, especially for sunsets and sunrises. This gives us some very dynamic lighting scenarios and moods to play with, all as a result of simply changing the sun's position. Altogether, the new improved sky enables us to achieve a variety of striking moods to enhance your images and inspire creative ideas. Alright, now that we've explored the new improved sky, let's reset the position of the sun again so that it's in the final position I've prepared for doing a production render. However, before we prepare to do a production render, I'm first going to switch cameras to a perspective of the motorcycle again. Let's then open up the V-Ray render settings and head to the Render Elements tab. In V-Ray 5, we have introduced an incredibly powerful new feature for post-production called Light Path Expressions. Light Path Expressions are an advanced tool available in the Light Select render element, which give you granular control for extracting specific lighting events from the scene to a separate channel. For example, when compositing your image, you can use Light Path Expressions to capture lighting, such as only self-reflections, or the first bounce of global illumination, or the GI that comes from the environment only, as well as many more specific lighting combinations. Let's go ahead and add a Light Select render element, and then take a look at its attributes. Since Light Path Expressions are a mode of the Light Select, the expression will capture contributions of the light that is added to the Light Select set. If the Light Select is empty, the expression will extract contributions from all scene lights. Note that we recommend rendering with Brute Force and Brute Force GI when using Light Path Expressions for the best results, especially when doing granular expressions, such as separating the different GI bounces. In the Extra V-Ray Attribute section of the Light Select, you'll find a Type drop-down menu. Here is where we can choose the Light Path Expressions mode. When selected, the expression box below becomes available, which enables you to type in expressions manually or right-click to access presets. These expressions describe a light path that starts from the camera and bounces around the scene until it reaches a light source. Expressions are constructed using a syntax consisting of symbols that represent a ray event or type. For example, if we right-click to access the menu, there is a list of basic symbols, which you can click and add to your expression or type in manually. These symbols are then combined with additional regular expression symbols, such as periods, asterisks, plus signs, and so forth. To see some examples, we have presets for a bunch of categories, including for V-Ray's built-in render elements and Light Select presets, which are meant to be used as a reference. Generally, it's faster to render the actual render element than using an expression, but these act as a helpful starting point for building your own more advanced expressions. We also provide ready-to-use presets, such as in the miscellaneous and object or material select categories, which let you extract specific lighting events that can only be achieved using Light Path Expressions. There is also a list of Boolean operations that allow more complex expressions to be rendered in a single channel. You can use these symbols to easily edit expressions by highlighting and replacing a symbol in your expression using the basic symbols list. For example, if I choose the GI from Environment preset, I can highlight and replace a symbol to extract something different. Let's highlight this letter B here for the background and replace it with the emitting object. You'll see in our symbols list that this is the letter O. Now, our expression is capturing emissive objects, so we've effectively written an expression to get the GI from self-illumination. As a general note, valid expressions always start from the camera, which we label with the symbol C. It then captures events on that ray path, for example, a number of refraction hits, and then we end at either a light, an emissive object, or the environment. These are the symbols L, O, or B respectively. For more information, you can check out our docs pages to learn more about syntax and constructing advanced expressions. Now I'd like to show you an example of how you could use light path expressions in a real workflow. Let's say that I'm working on a comp, and my supervisor wants me to have additional control over the global illumination so I can further tweak the GI in my render result. With light path expressions, we can split up the GI into 3 different components, which will allow us to then further manipulate them later in post before we combine them. To do so, we'll need 3 different light selects, with each containing an expression for one of the 3 components of GI. In this case, we've already set up an expression preset for the GI from self-illumination, so let's rename this render element to indicate that. Now I'll create another light select render element. Once again, we need to change the type to light path expression, and then let's locate the preset for GI from environment. Now I'll rename the element accordingly to keep things organized. Finally, let's add a third light select render element, and following the same process, let's now add the indirect diffuse preset. And I'll rename this to GI lights. Alright, now that I've got a light path expression set up for all 3 components of the GI, we could render the scene and then reconstruct the GI paths by adding them all together. To save time, I will load in an already rendered image into the VFB that I prepared in advance. This image includes the exact same light path expressions that we just made. Now, if I switch between the light select render elements here in the VFB, you'll see the results of the 3 separated GI components. Now let's hop over into Nuke, where I will show you how we can composite these components together to get the complete GI, and then do some basic color grading to tweak the results. Alright, here in Nuke, you can see that I've already got my comp arranged with the beauty paths constructed here using the necessary render elements. On the right here, I've also loaded in the GI render element so that we can see how it looks. To the left here, I've also already loaded in the 3 light select render elements, which contain the light path expressions to reconstruct the GI. You can see in the viewer here that these are the same render elements we just saw in the VFB. Now, if I select this merge node here, you'll see that I've combined these 3 light select render elements by adding them together, and the result we get is the complete GI. I can then select the color corrections here, and you'll see we've got the entire beauty paths reconstructed, incorporating the 3 light path expressions we used for the GI. The key benefit here is for scenarios where I need fine-tuned control over my image. In this case, since we split up the GI into 3 separate render elements using expressions, we can make adjustments to these specific GI components without affecting the rest of the GI. For example, I'm going to create a grade node and connect it here. Now you can see in the viewer that this node will tweak only the GI from self-illumination. Let's adjust its multiplier a bit in order to make the lights from the motorcycle here stand out better, and then maybe change their color. As you can see, with light path expressions, I now have very granular control over my image in compositing, and can polish it to my liking. Of course, this is barely scratching the surface of the possibilities with light path expressions. For example, we could break each of these 3 GI parts down further to target only the GI cast from one specific object onto another specific object, and then we could fine-tune that for total control in compositing. You can also do some plus and minus comp operations directly with light path expressions, meaning you could prepare in advance complex channels to simplify the compositing process even further. Altogether, the additional granularity that light path expressions provide makes them an incredibly powerful tool for having complete control over your image. Now that you've seen an example of how we can use these expressions in Nuke, let's return to Maya and prepare to do a production render. Alright, first I'm going to switch to the final camera I've prepared for our production image. Now, let's return to our render settings and get set up for doing light mixing and compositing. In order to use the new light mixer in V-Ray 5, we'll need to first add the light mix render element. When a light mix render element is added before rendering, the intensity and color of the lights and light-emitting materials can be changed directly from the VFB, both during and after rendering. For example, during IPR, you can adjust your lights from the light mix controls in one convenient location, rather than having to navigate to individual light parameters. You also won't need to re-render your final output to make tweaks to your lighting, meaning with a single rendered image, you can easily experiment with a wide variety of moods and lighting styles to find a look that suits your preference. Now let's head to the extra V-Ray attributes to make sure I have the light mixer set up properly for this scene. In the Group By dropdown, let's switch the mode to Grouped Lights, since I have set up this scene in advance by grouping the lights together in a sensible manner. This mode places the lighting information of each group of lights in a separate channel. Meanwhile, any lights not attached to a group are stored in their individual render channels. Now let's move on to add some other render elements we'll need for compositing. In V-Ray 5, we have implemented a handy new render element preset option called Back to Beauty. When I add it, you'll see that it automatically creates the necessary render elements to reconstruct the beauty paths in post-production. You can think of it like a shortcut that saves you time, while also making sure that you don't forget to add any critical elements you need to reconstruct the beauty paths in compositing. Now that I've got my render elements set up, let's get ready to do a production render. I'll take a quick look here at my V-Ray settings and make sure that my sampler type is set to bucket rendering. Then, I'll make sure my threshold is set to 0.005 so I get a nice and clean looking image. Alright, I'm going to leave all of my other render settings at the defaults, so let's go ahead and press render. Okay, great. The render has finished and everything is looking as expected. Now let's go ahead and take a look at the new light mixer and make some changes to our lighting to explore a different mood in our scene. To start, I'm going to double click on the handle on the right here to open up the Layers panel. Now, if we click on the source layer here, you'll see below in the Properties panel that we have the option to switch between the RGB, Light Mix, or Composite modes. Let's go ahead and choose Light Mix. Now, you'll see below that the Light Mix parameters and UI has appeared, listing all of the lights grouped by layers that I set up in the scene. Note that the information from light-emitting materials is stored in the self-illumination channel, and environment info is stored in the environment channel, which are both added automatically as groups. You'll also see that we have some controls along the top of this section, for options such as saving and loading light mix presets, a quick access icon for switching between presets, the ability to send your light mix modifications to the Compositor, or the option to transfer the light mix settings to the lights in the scene. Now, let's go ahead and do some light mixing. For a quick overview, you'll see that each light in the Light Mixer UI here has an option for toggling on and off its visibility, tweaking its color, or adjusting its multiplier value to make it brighter or dimmer. For example, I can click here on these checkboxes to toggle a light group's visibility. If I click the All option, all the lights will turn off, allowing me to then enable and focus on a light group in isolation. Now, let's explore how we can adjust the lights in the scene to shift from a daytime mood to a nighttime lighting scenario. I'll start by making some tweaks to the Rest channel here. You'll see that as I adjust its multiplier value downward, this dims the light in the atmosphere. All lights that do not fit into the other groups or individual channels are added to the Rest category, plus the atmospheric effects. I can also change the color of the light using its color swatch menu. This gives us incredible control over the atmospheric lighting here, and allows us to achieve a wide variety of different moods. In this case, I'll go for a light purplish blue color to create a nighttime or evening effect to work with. Note that generally, we recommend rendering your lights as a white neutral color if you plan on doing light mixing. That way, you can control the color of your lights completely in post-production, without any interference from the light's existing color tone. Okay, let's move on to make some further adjustments to the other lights we have here. I'll enable the environment lighting next, and let's change its color to a light pink. I'll then bump up its multiplier to something around 1.5, so we can see it better, helping to give our scene a nice soft evening tint. Next, let's enable the self-illumination, so that we're getting our emissive materials for the neon signs and motorcycle lights. Then I'm going to turn on the geolights group. which adds a bit more lighting from the signs and adds some smaller lights around the scene's geometry for the antennas and so forth. Great, so far so good. Now let's go ahead and enable the night lights. Perfect, those are helping to give us some light in the background there. Let's also tweak the color on these as well a bit, maybe going for a slightly reddish-orange color. And let's boost these up a bit as well. There we go, now that's looking pretty good. Next, let's go ahead and enable the lights group so we get some artificial lighting in the area with the buildings here. And there we go. Now you've seen how we can switch our scene's mood from a daytime to a nighttime lighting scenario, simply by making some quick tweaks to the lights using the light mixer, all without any need to re-render the image. If you're happy with your changes, but want to explore some other moods, you can also even save these light mix settings as a preset using the save icon here, or send these changes over to the Compositor to work on them further. In this case, however, I'd like to move on from the light mixer with a clean slate, so we can simply click on the Composite icon to switch modes and explore the new Composite layer editor. Now you'll see that we're back to viewing our original rendered image, and we can proceed forward from here to do some compositing. In V-Ray 5, we've now created a layer tree-based editing system where you can do nuanced color corrections, set blending modes, and combine render elements, all within the new VFB. The new layer system in V-Ray 5 applies corrections from the bottom to the top, meaning layers on top of the stack are considered in the foreground, and the result of all layers below is considered the background. The only exception to this is nested layers, which are executed after their parent, and we'll explore in a bit. For now, let's explore how we could do some color corrections on a single render element here. For example, let's say I want to tweak the global illumination. Let's head up to the Create Layer dropdown and choose the Render Element option. Note that we'll want to make sure that we've got the source layer selected here, so that it's an option available to us. Now you'll see that it appears as the RGB color layer here, since it automatically switches to that render element by default. We can adjust its properties below. In this case, let's switch the element to the GI layer. And note that since we added the Back to Beauty preset before we pressed render, we've got the GI and many other render elements ready for us to choose from. Now you can see that we've got the GI here as expected. However, in order to properly adjust only the GI, we'll first need to change the blend mode to subtract the GI from the full image here. This way, we'll have the image without the GI. Then, we can add another GI render element, which we'll have isolated and can then do color corrections on. To add this, let's go back up to the source composite layer, make sure we've got that selected, and then add another render element layer. Now, once again I'll switch the element to the GI, and then just to keep things clear, I'll rename it to GI-CC. Now, you'll see that its blend mode is already set to add, which is what we want so that it's being added on top of the RGB image. Now we can proceed forward to do our color corrections on the GI. With the GI-CC render element selected, let's go ahead and add a curves correction to it from the Create Layer menu. Now you'll see on the layer panel that the curves layer has appeared above the GI-CC render element, and there is a downward arrow next to it. This is indicating that the curves are being applied solely to its parent, the GI-CC, rather than the entire image. Let's go ahead and tweak the curve parameters here in the properties section below to make the GI pop out a bit more. If we double click on the curve, we'll create a new Bezier point, which we can then tweak by dragging on its handles like so. You'll see in the image on the left now that we're able to easily control and alter the look of the GI here. If I double click elsewhere on the curve, I can create a new Bezier point here and further refine my image to brighten it up a bit until I'm happy with it. Note that you can also right-click on the handles to switch between different interpolation modes. You can also use the Channels menu on the left to switch to a different RGB channel. In this case though, I'm liking how this looks already, so let's move on to take a look at the new Filmic Tone Map. If I want to add a color correction layer to the entire image rather than a specific layer, I'll need to deselect all the layers first. Then, I can go to the Create Layer dropdown and add the Filmic Tone Map so that it appears at the top of the layer tree and is applied to the entire image. In this case, however, you'll see that I've already got the Filmic Tone Map prepared and have been using it. Tone mapping is the process of rescaling the high dynamic range values in an image to within the visible interval. This is usually done in a nonlinear fashion, for example, with a custom curve, giving you control over the parameters of the tone mapping operator. Let's take a quick look at how the different tone map types here affect the image. You'll see that each type has a pretty significant impact on the end result and changes the overall light and dynamic range of the image. For this scene, I'm going to leave it on the power curve type as we had it, but let's also explore making some further tweaks below so you can see what the different settings do. The toe and shoulder controls here allow you to adjust the tone map's curve. For example, I can tweak the toe length or toe strength sliders, and you'll see the curve adjusts below along with the image. I'll leave these at just slightly lower values than we had it. I'll also play with the contrast a bit and bring that down a notch. Now, I'll also show you the shoulder length and shoulder strength parameters, and bring those up a tiny bit. Lastly, we have the white point, which I'll bring down a little. Now you've seen how these tone map parameters can be used to adjust the contrast and dynamic range of your image, while also giving you a convenient curve visualization below, which updates as you make tweaks. When you're done making changes, note that just like with the light mix, you can save a composite layer tree as a preset, using the menu icons up top. Finally, just don't forget to save your render out of the VFB by clicking on the save icon. Now you've seen how the composite mode makes it possible to go beyond rendering and get polished, beautiful looking images. But that's not all. We've also added many other features in V-Ray 5, including a new camera exposure value setting. This means you can input a straightforward exposure value to control image brightness. You can then adjust the exposure value while using shutter speed and f-number values for motion blur and depth of field respectively. We've also added material presets to the V-Ray Hair Next material. Now, you'll find a wide selection of natural hair stylings out of the box. You can then customize and tweak the preset's parameters further to find a look that suits your image. In addition, we now support an experimental out-of-core GPU render mode. This means you can render on GPU even if your scene exceeds your GPU VRAM limit. Note that since this is currently an experimental feature, it is not yet supported for RTX cards. And once more, the new features in V-Ray 5 are all supported for both V-Ray and V-Ray GPU, meaning you can choose whichever render engine that best suits your setup. Now you've seen how in V-Ray 5, you'll have a plethora of powerful new features at your disposal that make it easy to work faster, improve the realism of your renders, and take your images beyond rendering with the powerful post-processing tools available right out of the box. In addition, the new Vray Proxy offers impressive functionality that makes it more useful than ever, while also giving you increased performance. The new material improvements all serve to speed up your workflow and take your renders to the next level. Meanwhile, the new randomization options and the procedural streak parameters in the V-Ray Dirt offer straightforward controls for making your textures more realistic and simple to tweak. What's more, the new light path expressions give you incredible, fine-tuned control over all aspects of your image's lighting. And of course, the new V-Ray Frame Buffer improves your workflow with its intuitive new layer editor and powerful light mix and compositing modes, which make it possible to do a wide variety of post-processing tweaks, all within V-Ray 5. If you'd like to try out V-Ray 5 for Maya, please visit our website, chaosgroup.com, for more information and to download a free trial. If you have any further questions, please feel free to check out our docs page for additional information about these new features as well. And for the latest updates, please click subscribe on our YouTube channel, Chaos Group TV, so that you can keep up to date with our latest new products and releases. Thank you for joining me for this webinar session, and I hope to see you next time.